So the next thing that's misleading is what we call the area principle. So we often use images to compare certain amounts to each other. So we make a lot of graphs like that. So we call those pictographs, actually. Pictographs. So this is a pretty common way of displaying information. And usually it's not like trying to be misleading. I think it's just happens by accident because people aren't paying attention. So larger images should always correspond. So we rate it so larger images correspond to greater amounts, smaller images to smaller amounts. To use images properly in this way, we must follow a rule known as the area principle. So what the area principle tells us is that amounts, when are compared by constructing images for each, the areas of the images should be proportional to the amounts. For example, if you have twice as much of one item than the other, then the other image's area should only be twice as much. That being said, like let's say what I was trying to show you is, my cheese production. So I give you a slice of cheese like this. There's my cheese. So usually what happens is if my cheese doubles in production, we get an image like this. And that's way more than double. Because what I did here was I only doubled one dimension. I was going, I'm going to double this dimension. But when I do that and I try to make the picture all look the same, everything else doubles as well, because then this dimension doubled as well. So it balloons it out. So it's not double in area anymore. It's like 4 times as much area. There's ways that we could deal with that, as in if I want to show this pictograph and I just want to show it just doubling in area, is I would just make maybe 2 slices of cheese. Just put them next to each other. So remember, I'm drawing this by hand, so it's probably not going to be twice as much size. That would make more sense. I've doubled the area and I showed it in a good way to show that it's double. So example here would be the cost of jet fuel in 2016 was 93 cents to the gallon. In 2019, it had almost doubled in price to $1.78. So had you looked at the bar chart, we see, yeah, it doubles. And bar charts are a good image where we usually can show doubling of area. This area here is twice as much as this area here. The problem is that when I try to make a picture image like this, so I have this jet. So it's showing you, what's supposed to be showing you is that it doubles. And like I said, usually the problem is focusing on one aspect of the dimension. So we focus maybe just on the height of this image. And what we do is go, hey, I want to show I have twice as much. I double the height of that image. Well, when I do that, that's not the only thing that doubled. The length of my image also doubles with it. So as you know, with anything with area, if this is, when I double 2 sides, I'm basically making that image 4 times bigger when I'm only supposed to show it being twice as much bigger. So this is 4 times larger when it's only supposed to be 2 times larger. So this is this problem that we have when we try to do pictographs, is we're not careful with the images. So it's not always getting bigger. This is another one. So this is showing the purchasing power of the Canadian dollar. So in 2000, a Canadian dollar was worth $1 US. And then by 2020, we'll go back one to make it a little easier. 2015, then a Canadian dollar is only worth 75 cents in the US. So what we see here is that the price is decreased by a quarter. So that's what you see here. So it's trying to demonstrate this decrease by a quarter, but here's the problem, is that the 2015 purchasing power, is actually 3/4 of the 2000 purchasing power. So it's decreased by a quarter, but really what we did is we retained like 3/4 of the power of the purchasing power. The images, however, if you compare like this image to this image, the image is 1/4 the size of the 2000 coin. So like I said, what we actually know is going on, the actual decrease, I mean, actually what it should be is 3/4 of the size, because we still retain 3/4 of that value, but what this image is showing me is 1/4. Probably because there's this little bit of this confusion here by it decreased by a quarter, therefore we only show a quarter of it. But like I said, that's also, it's very misleading. It looks like the value has decreased a lot less, it's much smaller than it used to be. Because this is, like I said, it's only a fourth of the size, when really it should be 3/4 the size. It should be closer to maybe this size. And then this was a really fun one. So I found somebody had made a Twitter post about this. So this was a graph doing the average height of women. There's actually two things wrong with this image. I don't know if you noticed right away. So one is the pictographs. So we got a person here, and we want to show somebody is bigger. They've increased by both dimensions. They're taller and wider now. So we made them much bigger. The other problem is this is definitely not 0. This is probably like, if I was to make a guess, maybe 4 feet 10 inches here. That would be my guess. So we're not bottoming out at 0. So this is a graph that's not only area principle, but it's also that vertical axis principle. So like I just thought it was funny because here we go. As an Indian woman, I can confirm too that too much of my time is spent hiding behind a rock, praying that the terrifying gang of international giant ladies and their Latvian general don't find me. Yeah, so really what we're supposed to show is that people in Australia, Scotland, Peru, they're all about the same height. South African women are a little smaller. Indian women are averaging a little smaller. And Latvian women are a little bigger. There's not a big difference here, right? This is like a difference of 1 inch. From here to here, that is a difference of 5 inches. So this is a combination of two things, the thick graph and the vertical axis. And then just because I thought it was funny, there is that giant woman on the last graph here.